In this lesson, we are actually going to start solving our trig equations. We're going to use some of the operations that we've been doing, so add, subtract, multiply, and factor. And you'll also need to make sure that you have a unit circle readily available unless you have it memorized, because all of our answers that we're going to get should fall on our unit circle. So when we are solving for trig equations, you've got to isolate the trig function first. Then you're going to determine the angles or the radians that satisfy the value in your equation. And we're only going to look at one full cycle. So we're only going to look from 0 to 2 pi. And you'll notice I have this in interval notation in brackets, meaning you're going to include 0 and 2 pi. So if 0 is a solution, 2 pi should also be a solution. Another little quick note is we're going to be answering everything in terms of radians. However, if you are given an example in terms of degrees, make sure that you answer it in degrees instead of radians. So here's our first example. Solve sine of x equals 1/2 on the interval from 0 to 2 pi. Okay, so what this is asking me, remember sine is your y value. So I want to know where on the unit circle does my y value equal 1/2. Now, technically, in order to isolate the angle, we actually show the step of taking the inverse of both sides of the equation. So I'm going to write this for you one time so you can see it, and then we'll just kind of shortcut it from here on out. And then we would do sine inverse of 1/2 on the other side of our equation. Okay, and the reason that we're doing that is because sine and sine inverse will undo one another, leaving us with just x, which is representing our angle, and that equals sine inverse of 1/2. So if I know the angle measure and take the inverse of it, then it'll give me the coordinate. And what we also have to take into account is where is sine, and in this case positive, not just 1/2, but positive 1/2. So you have two quadrants where sine is positive, definitely in quadrant 1 and again in quadrant 2. So I want to know what two radians does my y value equal positive 1/2. Well, I see one of them right here at 30 degrees, which is pi over 6. And then I see the other one on the other side at 150 degrees, or at 5 pi over 6. So sine of x equaling 1/2 is a true statement when your x value or your angle is pi over 6, and then again at 5 pi over 6. Okay, example 2. Solve for tangent of x equaling the square root of 3 on the interval 0 to 2 pi. Okay, so let's take a step back and let's first look to see, in this case, where is tangent positive? It should be positive in two different locations, definitely in quadrant 1, and then again it's in quadrant 3 where it is positive, and that is because tangent is the ratio of sine divided by cosine. So I want to know where is my y value divided by my x value, or x coordinate, equal to the square root of 3. Okay, we can definitely be for sure that that is not going to happen at the pi over 4s, 3 pi over 4, 5 pi over 4, and 7 pi over 4, because when you divide root 2 over 2 by itself, or by negative root 2 over 2, you'll get positive 1 for tangent and negative 1 for tangent at those values. Okay, so I know it's definitely not at the pi over 4s. If you remember things that we talked about back in from the unit circle a while ago, hopefully you can remember these. If not, we'll practice through. So let's go ahead and look at tangent of pi over 6, because I'll have the same value around each of the pi over 6 radians. So tangent would be 1/2 divided by the square root of 3 over 2. Since both numerator and denominator have a denominator of 2, that reduces to give me 1 over the square root of 3. So tangent of pi over 6 rationalizes to be square root 3 over 3. It might help you to write each of these around your unit circle in your notes as you're going through. Okay, so that didn't give me the value. So the other one to check would be tangent of pi over 3. So tangent of pi over 3 would be the y-coordinate, root 3 over 2, divided by 1/2. Again, both numerator and denominator have denominators of 2, so that would simplify to give us root 3 over 1. So in fact, tangent of pi over 3 equals the square root of 3. Okay, so that kind of helped us get our value so that we don't have too much work to do. Again, once you know tangent in anything in the first quadrant, you can just reflect it around to get your positive and negative values in each of the quadrants. All right, so back to our original equation. Tangent of x equals the square root of 3. Again, to isolate x, we need to do tangent inverse of the square root of 3. And we've determined that tangent has a value of positive root 3 at pi over 3. And then again, tangent is positive in quadrant 3, so I want to find the radian that would be have that positive value for tangent being pi over 3 to give me at 4 pi over 3. So those are your two solutions for this example. Okay. Example 3, now we want cotangent of x equaling positive square root 3 over 3. So remember, tangent is sine over cosine, so cotangent is its reciprocal, cosine over sine. So if we know that we just found in the last example that tangent of pi over 3 simplifies to give us the square root of 3, when I write its reciprocal, cotangent of pi over 3 would be 1 over square root 3. And when you rationalize, you multiply by square root of 3 in the numerator and denominator, we'll get square root of 3 over the square root of 9, which is just 3. So I know from the previous example that cotangent of pi over 3 equals square root 3 over 3. Okay. We also need to be looking at, do we want the positive or negative value? In this case, we want positive, so cotangent will be positive in the same quadrants as tangent. So it's positive in quadrant 1 and in quadrant 3. So cotangent of x equals the square root of 3 over 3. The step you should show to prove that you've got your you're showing your math correct is to take the inverse, cotangent inverse of root 3 over 3, and that simplifies, or that gives us the values of, again, pi over 3 and 4 pi over 3. So I have two different solutions. Most of the time you're going to get two different solutions. If you're landing on one of the quadrantal angles, so on your axes at 0, 90, 180, and 270, and then back to 360, you may only get one that works. So just be mindful of that. Those are really kind of the only places. All right, our next example, secant of x equals 2. Solve that on the interval from 0 to 2 pi. Okay, secant is nowhere listed on our unit circle. Our x values equal cosine, our y values equal sine, and our ratio of y over x equals tangent. So we have to remember that secant is the reciprocal of cosine. So if I want to relate it in terms of cosine, I can change secant equaling 2 over 1 to be the reciprocal. Cosine of x equals the reciprocal of that value, which would be 1/2. Okay, can we find cosine equal to 1/2? Do we have an x value equal to 1/2, positive 1/2, on the unit circle? And in fact, we do. So if you look around your unit circle, our x coordinates are positive in quadrants 1. That's the other thing. List your quadrant. It's positive and 1, and then again in quadrant 4, those are where x's are positive. So at pi over 3 and at 5 pi over 3, my x's are positive and they equal 1/2. So again, we wrote the reciprocal of secant to be cosine. So the reciprocal of 2 is 1/2. And now I'm going to show that I'm taking the inverse, cosine inverse of 1/2, so that I can solve for x to have a value of pi over 3 and 5 pi over 3. Now I know several of our examples have had values of pi over 3. That's not going to be true for every single problem. It's just kind of worked out for these first few that we've gone through. All right, example 5. A little bit different. Solve sine of x plus the square root of 2 equals negative sine of x. Okay, so it said that we always want to isolate our trig function that we have. So your choice is to either add sine of x on both sides of the equation or subtract sine of x on both sides of your equation. I'm going to go ahead and add the sine of x on both sides. So that would give me sine of x plus sine of x is 2 sine of x plus the square root of 2 now equals 0. Okay, so now I can continue getting sine of x isolated so that I can take its inverse and find the value on the unit circle. The first thing that we should do, order of operations, work them backwards, subtract the square root of 2 on both sides of your equation. And then to further isolate sine of x, I need to divide both sides of our equation by 2. Okay, and now we have sine of x equals negative square root 2 divided by 2. So I need to first know sine equals the y value, and what quadrants is it negative? So our sine being negative is going to be in quadrants 3 and quadrant 4. So I want to know, where do my y values equal negative root 2 over 2? And I'm looking in quadrants 3 and 4. Remember, these are my favorites. I love the root 2 over 2's because they're always related to the pi over 4 radians. They're always the same. So at 5 pi over 4, my y value is negative root 2 over 2. And at 7 pi over 4, my y value is negative root 2 over 2. Show that step to show your arithmetic work. X equals sine inverse of the square root of 2 over 2. Therefore, our two radians where sine equals negative root 2 over 2 are at 5 pi over 4 and 7 pi over 4. There are your two solutions. Great job, guys. Just a few more for today's lesson. Example 6, solve tangent of x plus 3 equals 0 on your interval from 0 to 2 pi. So one stepper just to isolate tangent of x by subtracting the square root of 3 on both sides of our equation. Now that tangent is isolated, I want to know, where is tangent negative? So that's going to happen in quadrants 2 and quadrants 4. And then where is tangent equal to negative square root of 3? Okay, so remember, we went through these a few moments ago with one of our first ones. At pi over 6, tangent is root 3 over 3. At pi over 4, tangent has a value of 1. At pi over 3, tangent has a value of the square root of 3. And then as we continue around our unit circle, those values for the pi over 6, pi over 4, and pi over 3's would be the same. They would just change the sign based upon where tangent is positive and tangent is negative. Let's go ahead and fill in the others. Tangent of 0. 0 divided by 1 would be 0. That would also be true at 180 degrees, 0 over negative 1, or at pi. Tangent of 90 and 270, so at pi over 2 and 3 pi over 2. In this case, tangent is undefined. So you won't have a solution if we're trying to solve for tangent at pi over 2 or 3 pi over 2. Okay, so tangent of x is back to negative square root 3. Again, I need to use quadrants 2 and 4, and those will occur at 2 pi over 3 in quadrant 2 and 5 pi over 3 for quadrant 4. So x equals tangent inverse of negative square root of 3. So my values, again, where tangent equals negative root 3 are at 2 pi over 3 and again at 5 pi over 3. Two solutions. Okay, example 7, 4 cosine of x equals 1 plus 2 cosine of x. Solve on the interval of 0 to 2 pi. So we're going to do a little bit more cleanup on this one like we did in a previous example. Get all of our cosine terms together. So let's subtract 2 cosine of x on both sides of our equation. This leaves us with 2 cosine of x equals 1. I need to further isolate cosine of x by dividing by 2. So cosine of x equals 1/2. And we are looking to see, where is cosine positive? Question mark. Okay, that is quadrant 1. Everything's positive in quadrant 1, and our x's are also positive in quadrant 4. And where does cosine, the x value, equal positive 1/2? Again, we keep coming back to these square root or the pi over 3's. They don't always work that way, but they are for several examples. So at pi over 3, the cosine value is 1/2, and at 5 pi over 3, our cosine value is also 1/2. So x equals cosine inverse of 1/2, therefore the radian or the angle measure, pi over 3, which is 60 degrees, and 5 pi over 3, which is 300 degrees. And this is our last example for this set. This one has actually already been solved, or excuse me, factored for you. So you'll notice that this is written as a GCF, sine of x, multiplied by a quantity, sine of x plus 1. You will, in our next lesson, actually have to factor some problems. So factoring didn't go away, we just took a break for a day. So we're going to solve that equation, again on our interval from 0 to 2 pi. Since it's already factored, the zero product property states that if 2 or more things are being multiplied and equal 0, that means any of those particular factors could equal 0. So I'm going to set sine of x equal to 0, and then I'm going to set sine of x plus 1 also equal to 0, and we'll solve them individually. The first one is already isolated, sine of x equals 0. So x equals sine inverse of 0. And again, I want to know, where does the y value equal 0 on the unit circle? Well, my y value is 0 at 0 degrees, at 180 degrees, and then back again because we're including 2 pi at 360. So we have three solutions, 0, pi, and 2 pi. And that is where sine of x equals 0 for this example. Now we're going to solve the other factor. Sine of x plus 1 equals 0. We're going to solve for sine of x by subtracting 1. Isolate that. Okay, so make yourself a note. I'm looking, where does sine equal? So where does my y equal -1? Okay, so my y values are negative in quadrants 3 and quadrants 4. And then y equals -1 only in one place, right down here at 270 degrees, or at 3 pi over 2. So now we know our answer, and we're going to show our work. X equals sine inverse of -1, so that value is 3 pi over 2. So for this particular example, because we had two different factors to solve for that were already factored for us, I got three solutions for the first factor, that GCF, and one solution from the second factor. So we ended up with 4 solutions for this example. Great job, guys. This was our first day of solving trig equations. Again, these are quote unquote the baby ones, getting your feet wet, making sure that you kind of understand what the process is, and make sure that you're practicing the work that goes along with it. Do all of them, get it down pat, because you will have several reciprocals in there for you to practice as well, and those are probably the ones that will trip us up more than anything. Have a great day and get that practice in.